I feel like one of those people on the phone. This call could be recorded. All right, so let me make sure I did what we wanted to do. So 100 to 20, those are all good. N is 16 for now. X bar is 92. The numerator is X bar minus mu, which is good. The bottom part of our denominator is the square root of n, which is good. We want to divide sigma by the square root of n, which is that. And then we want to take the numerator, 10, divided by the denominator. So 1.6. And 1.6, the probability of that, do I have a T, a Z? I do. .6. Hi, Anna Grace.
Hi, I just joined. Did I miss anything so far?
Nah, just me fumbling around.
All right.
So 1.6, 0.0548. All right. So back to my model, probability that X is between 92 and 92.5. So what I did for everyone, Anna Grace included, is I just set this up in Excel because I knew the evil Pearson was going to keep asking me questions. And so questions are great, but I'm trying to save myself a little bit of work here. So what I did was I just found out the probability for an X bar of 92. That was the previous question. So I'm just going to copy this sheet. All right. And so what was that? What did I put up here? 0.0548. Just going to park that over here. And now my X bar, so I already have it for 92. I'm just going to write this. This is the probability for 92. Well, what is the probability for 92.5? So I'm just going to go up here and change that to 92.5. That gives me a z-score of negative 1.5. What does that turn to? That's 0.0068. 0.0068. Let's see what happens when I subtract these two. I think what I want to do is subtract the bottom one from the top one, because if I do it otherwise, I'm going to get a negative number. 0.048. So that should be what this answer is. 4 decimal places. I don't like that. So I know how Pearson is. I'm going to add a 0 on the end and see if this works. Now. Okay. What did I do wrong? Let's see here. That's that.
Try it without the 0. That's just what I do.
Okay.
If it says it doesn't want it. Okay, never mind. Sorry.
That's all right. Let me think here. Between 92.5, something's not right. I wonder if I did this right. 92.5, it's still going to be a negative number because it's left to the mean. That's negative 1.5. Did I go too fast here? 0.668. 06. I goofed. 0.0668. Everybody see that? So I made a mistake. So this I should take the bigger number and subtract the smaller number. Slow is fast. I went too fast and made a goof. That looks right. I'm going to add a 0 on the end. Well, let's go with the Lexi.
It all depends on the day.
There you go. So the Lexi rule works.
So I'm confused. How did you get the first answer, like for part A? I think I missed that. Like,
Yeah.
I don't think I logged on yet.
That's okay. So Anna Grace, what I did here was I took all these givens for the problem and I made a little space for them. So with the mu of 100, so I just parked that right there. You see, I can't get that any bigger, but you see up in my function, can I? Okay, thanks for no help. But I just parked that there. You see what I did?
Yes, sorry. I didn't realize I was on mute.
Oh, no, it's okay. And then I did the same for my sigma. I just parked that there. And then I have an n of 16, and I parked that there. And then it says, so I'm just going to rename this tab A. So we're all on the same sheet of music, literally. And here is asking me, what's the probability that X bar is less than 92? So I'm going to put 92 in for X bar. Now, down here, let's just do this to put some icing on the cake. So everything with a yellow box is some sort of computation that happens because I have referencing going on.
Okay.
So in the numerator, that's the numerator of my formula. Remember, my formula is X minus the mu for the numerator.
Okay.
Does that make sense?
Yes.
Okay. Now, this is just I hate to even say a Shatskinism because that sounds like I'm LeBron James or something like that. But, or someone else. I shouldn't even say that. The point is that you could do this any way you want to. You could do this whole thing any way you want to. What I did here was I started with the bottom of the denominator, which is the square root of n. And then I took that square root of n and I put sigma divided by the square root of n. I could reverse these, whatever way makes sense. But
Okay.
I'm just kind of doing my denominator computations one step at a time.
Okay.
Does that make sense?
Yeah.
So I'm starting with the square root of the n. I get that there. That's 4. And that references this cell up here, the 16. And then I know that I have to take sigma, divide it by that 4. So this cell takes B6, which refers to sigma, and it divides it by that value of 4. And now to get this value, I have to take the numerator divided by the denominator. So I have to take B10 by B13. And Anna Grace, I'm recording this right now. I have a model like this on a spreadsheet I can send you and post so you can look at. I don't want you to get hung up on the cell references because I think you could figure that out later. The
Right.
main thing is I'm parking some givens up here and then doing my referencing so that I get that.
Right. Okay. I get that now. I didn't know really what like like 1 and 2 meant.
Yeah. And
But
they don't,
okay.
you know, I mean, this could be kind of confusing. I don't know. I think in terms of PEMDAS, I need to, I don't know. I don't know if there's even PEMDAS involved. I just like to break it out like this.
Mm-hmm.
But again, there's no right way. There's probably 40 different ways of doing this here. And then I looked up the Z on the table.
Okay.
So then once I have this base model established, I copied it here so I can use it again. because as long as I'm not messing with anything down here, I can just change these up here, these givens up here.
Right.
And that's what I call modeling. Some people call it cell referencing, but cell referencing doesn't sound as exciting to me as modeling does. So anyway. Okay, so
Can we
go ahead.
can we set up our Excel like this for the exam? Would that count as like showing our work if we have them separate sheets?
Yeah.
Okay.
Yeah. Absolutely. In fact, to each his own. Some folks swear by the calculator because this stuff confuses them. And I say go with what works for you. If what works for you gets, old-fashioned calculator and pen and paper, then go for it. If this is easier to you, then do that. I'll take any of it and I'll look at it all to see what you did.
Okay.
The worst thing to me is just a number on a sheet of paper, 49. And I'm like, you know what I mean? I'm like, I don't, and the worst thing is when it's not 49. And I'm like, okay, I don't know how you got that. Okay, so so to do problem B over here, we just copied this A. And again, I don't mess with anything down there because those are all references. Okay, I can mess with stuff up here because I've made it. So those are just entry points of givens. So kind of like church and state. I'll just keep the integrity right there. And then I have to do some looking up here, although Excel can do that for me too. But anyway, so let's do C. And I'm just going to copy this model once again. Put it down there. And I'm doing this kind of pretty right now. I mean, on the exam, as long as I know what I'm looking at, it doesn't need to be pretty. Okay. So you don't need to do all this kind of icing on the cake stuff that I'm doing right now. You don't need to color code stuff. That's not what this is about.
So if
here,
we kind of name it like question 1 part A, question 1 part B, that kind of thing.
Yeah.
Okay.
Absolutely. And even then, if you don't, I'll find it. I'll find it eventually because I'll be looking for it. And, so don't, this isn't a fashion show, but I got to know what I'm looking at too. So to me, the difference is just labeling what we're talking about. You see what I mean? And I don't care what you name these things. So let's do this one, C. What is the probability that X is above 101.8? So right off the bat, I'm just going to make a mental note to myself over here that this is a more than problem. Okay. And when I do a more than problem, it cues a 1 minus. Okay. So I'm not going to do anything with that just a second. But when I go to my Z table and I get that value, I know that I'm still not done until I do a 1 minus because the above is to the right of that value, not to the left. And whenever I'm to the right of that value, that means I got to do a 1 minus. So that stays the same. That stays the same. That stays the same. The only thing that changed was that right there. So we're just going to enter 101.8. That goes down to z-score 0.36. Go here to my handy dandy Z table. All right. Go down here to 0.3. Walk on over here to 0.06, 0.6606. Remember, that's not the answer. 6406. I still got to do my 1 minus. So I'm going to do that right here. Literally 1 minus. I'm going to reference that cell right there. Boom. 0.3594. I should be able to go over here. 0.3594. Why, thank you. All right. There's a 65% chance that X is above what value? Okay. This is the one you were having problems with, right, Lexi? Okay.
Yeah.
All right. No worries. So let's see here. So I don't think this is probably the way to do this right here. We'd have to set up a new spreadsheet, which we could. I don't know if I feel like doing that. So instead, I am going to, let's say, I do this. Can I do my whiteboard? Can y'all see my whiteboard?
Mhm.
All right.
Yeah, I can see it.
Okay. So this is a case where I have a probability and I want to get a single value. What I call the reverse. Okay, so first things first, and I think this might be what's hanging you up, Lexi, although I don't let me speak for you, I could be wrong. I want to convert that into that.
Okay. Yeah.
All right, and then I'm going to shrink down like my TV, and I'm going to enter the Z table. And I'm looking for that number right there. Okay. So, can y'all see the Z on my screen?
Yeah.
Okay. So this time I'm on the inside here. Nice and small, zipping around. Where is it? Where is it? Ah. Pearson is being Pearson. It's somewhere right there. See what I mean? It's not here, 0.6517, and it's not here, 0.6480.
Wait, I don't think we can see.
Okay.
No, the Z table's not on there.
Yeah.
Z table's not showing up?
No.
Mm-mm.
I thought you meant that Z that you drew on there.
I did too.
I was like, yeah, we can see it.
You just can see this now.
And then I'm like, what is he exactly pointing to right now?
No, that's why I count on you guys. I make mistakes all the time, and I'm sitting up here, and now I know, you guys are like back there going, what the hell? Okay, we good now? Z table?
Mm-hmm. Yeah.
Okay. So where were we? We're down in here. We're Mike TV running around. And this is what I'm talking about. So see how that number above my cursor is 0.6480?
Mm-hmm.
And then this number is 0.6517. Well, there is a 0.6500, but it doesn't go to a clean break on the Z table. And this is probably where I failed you a little bit. I'll just tell you this right now. You're not going to see a question like this on the test where you have to go even farther into the Z table. See what I mean? This is
Mm-hmm.
where my desire for you to navigate the Z table ends. So I honestly don't know how, let's do something real quick. Let's take those two numbers, 0.6, 0.6480. 0.6517. Because this is just kind of a pain, and it's just not a pain that I'm interested in. So that's kind of telling me that's pretty doggone close to 0.65. And what I just did was I essentially did a z-score of, where am I at? Where did I go? So a z-score of 0.385. No, 0.385. Yeah, that's correct. See what I did?
Mhm.
That's the 0.3. That's the hundredths position. So I went out to the thousandths position because that's halfway in between. So just to write it here, 0.385 is the probability. I'm just going to go with that. So what do I do with that number? Well, I'm going to go back to let's see if my whiteboard is still up there, and it's not. Oh, there it is. Okay. Can you see that, Z?
Yeah.
All right. Okay. So let me back up. Sorry, Charlie. Okay, so the formula we want to use here is we're solving for single value x, and that formula is z times the standard deviation plus population mean. Well, what did I just say? 0.3. That's not a probability. I wrote it on that Excel sheet as a probability. It's not, it's a z-score. 0.385 times our standard deviation was, what was it? It was 20.
Why is it single value x and not x bar?
It is, right. It is single value. It is X bar. So I got to adjust my formula slightly. Let's do that. Thank you. So, so that means that fighting the computer. Which means, and N was 16. All right, so here's where we're at in terms of setting that one up. So Lexi caught it correctly. This is the correct formula. Let me just put that cherry on top. Z times sigma over the square root of n plus the mean. We're going with this because of what we just talked about, the Z of 0.385. Pearson might want us to round that up to 0.39. I guess we'll see. Because z-scores usually come in 2 digits to the right of the decimal and not 3. This is correct. And that's correct. Everybody with me?
Mhm.
So we know that this here is going to be 5. Hi, Thomas.
How's it going there?
All right, we're just shaking and baking or something like that. Let's go over here. Let's go over here. And let's get bigger. So, Z. I'm just going to put sigma. Square root of n. Cheat a little bit. I know I shouldn't do this. That's just bad. This is going to be a sloppy model. Whatever. So, and then that X bar. So let's work our way top to bottom. That is 0.385. That is 20. This over here is 16. This over here is the square root of that. And the truth is, we probably didn't need a new whole spreadsheet. I'm probably making this much more overcomplicated than it needs to be. I just want to lay this out a little bit more. So this is going to be that divided by that. And so that M is, what did we say, 100? So this sucker is going to be that times that plus that. And we don't have to do anything special because the PEMDAS is already there left to right. As I sigh before we go into the evil Pearson. So let's see if this survives contact and Pearson is forgiving or not. Rounded to 2 decimal places. Awesome. Here we go. 101.93. All right. Is somebody out there doing like a Pearson dance? Something? Here we go. Ah, we get the evil box. Okay, fine. Be that way. Let's try this. Let's round this up. Well, that's nice. That rounds that up. Let's try this down here. Let's put it at 9.5. Take a deep breath. Okay. I think something's going on with this. I just don't know what. That is the heart of the problem. Because this is that, that's going to be that, that's that. Okay? So if anything, it's that right there. Let's just check our stuff again. So 0.6500 is between those two, unless I'm missing something. Maybe we round, that would be dumb. We did round 0.39. Did we try that? We did.
That's where it would get me because I'd use like the one above the
Yep.
percentage and it would say it was wrong, so I'd use the one below and it would say it was wrong too.
The correct answer is 98.07. Okay, I did something really wrong then. That's more than just a Z-score wrong. Ah, I know what I did wrong. Dang it. It's much simpler than that. Anybody take a guess what I did wrong? Let me think here. There's a 65% chance that X is above what value? I'm gonna try
You need
this.
to do 1 minus the.
Yeah, well, I think it has something to do with that. Let me see here. I'm having a brain cramp. 65% chance that X is above. I think we'd still find the Z score. But I feel like I'm missing a step. Let's draw this. Man, we can't really, because it's %65 chance. So we want this to be 65%. So if the mean is here, that means that this value, 65%, is above. That means this is going to be 35%. So if I turn that, let's see what happens when I go into the Z table with 0.35. And look for that. Okay, where's my Z table? So I'm looking for 0.35 this time. And it should be on the other side because I'm to the left of the mean. Still doesn't give me a, oh, that's 0.03. My bad. .35 still doesn't give me a clean one. But I'm just going to guess at this point that the z-score is a negative 0.385. Does everybody see that? And that makes sense because it's symmetrical. Yeah. Everybody with me out there? I am. You want to say hi to some warriors?
Oh, hi, Warriors.
Hello.
Sorry, I didn't realize you were in class.
No, we're confabbing. This isn't a class. This is like a special session. Don't tell anyone.
Okay. Well, nice to meet you all.
All right. Everybody see where I am right now? Everybody tracking on my
No.
logic? No?
It's showing the whiteboard.
Okay. All right. So if I go into the Z table and I look for 0.35, that is somewhere in
Okay, yeah.
between these two. And so that corresponds to a Z of negative 0.385.
Mhm.
Let me just, well, it's somewhere between a Z of negative 0.38 and negative 0.39. So I'm just going to go with this for now. Check that out. You see that, Lexi?
Mhm.
That's pretty close to that. Although I wonder if the evil Pearson would have given me credit.
I have a question.
Okay, that makes sense.
What's up, Anna Grace?
So I have to go in a few minutes because I have an appointment at 2, that I have to get ready for work. But are you gonna post this recording?
Absolutely.
Okay.
Yep.
Will you be able to post it today? Because I was planning on working on this today.
Yeah.
Okay, cool.
Yep. It'll take, I mean, I have a little bit of lag time because it takes a few minutes to upload and stuff, but it'll be up today.
All
Absolutely.
right, cool. Thank you so much.
Yeah. Thanks for punching in. Good luck on, or no, you're going to work.
I just have like a work call.
Okay.
Yeah.
All right. Well, take care. Have a good weekend.
Thanks, you too.
Yep. You bet. Okay. So, I guess that's what's going on is we have to think about above and below. And I think the bottom line, Lexi and Thomas, Carrie, I guess, took off, is drawing a picture probably doesn't hurt, even with the sample mean. And if we're looking at a 65% probability under the curve, we change that to a 0.65. We think about where, like my drawing on the whiteboard, where that's supposed to be. And if it's left of the mean, then we should be doing a 1 minus on the probability that we're given before we go into the Z table. Because that's what we did. We took the 65, we turned it into a decimal, we did a 1 minus to get the 0.35, Then we went into the z-table to look to see what z-score the 0.35 corresponds to. And then we put that into our equation and work our way back out. Does that make sense? But now I'm just questioning if I covered this very well in class. And if I'm having that much kind of a brain lock, either I'm really tired or I didn't cover it very well. So at this point, I think I need to kind of take that into consideration. Doesn't mean that that's not a fair game to ask you a probability question, but I need to think about how I phrase it so that I'm not trying to pull a rabbit out of a hat.
Mhm. So when you're asking basically for the 65% chance, we want to take the other end of the percentage.
When it's because it's asking for the above.
Above, okay.
So if this question was there's a 65% chance that X is below what value, then I think the answer I had before. So really, if it was,
Would have been right.
yeah, exactly. This would just turn into a
Okay.
positive value right
Okay,
there.
that makes sense.
And then that would be, and that makes sense because it's the right of 100.
Mm-hmm.
And that probably, because if it was right on 100, that'd be 0.5. That'd be 50%, right? Because that's the normal distribution is symmetrical. The fact that it's 101, it's a little bit to the right. And so that makes sense that it probably corresponds to 65%. When it's X bar is below what value, well, that really we got to do a 1 minus on that. We're talking about there's a 35% chance it's below what value. And so that's why we would turn this to negative and get that. And that's left of the mean, like we would expect.
So would it work if you just did 0.38? Because like if I would have gotten 98.075, I would have rounded up to 98.08 and probably got it.
You know, that's where I'm wondering it might have something to do with this, and how I got that. I'm assuming it's 0.8385.
Mm-hmm.
But I didn't take an average of those two. I did before, so I don't know.
Right.
And I don't know if Pearson
Okay.
would give it to you if you rounded up, or not. So if you
Mm-hmm.
rounded it to 98.08, I don't know if they'd give it to you.
Right.
So what else?
I think that helps because that was just my other issue with the sampling homework. Because after you sent out that email and I sat and worked through it, I was able to get the one I had sent yesterday.
Okay.
So I just want to ask about this problem.
Yeah. Like I said, I'm still not happy with D in terms of I think I missed going over that as well as I would have liked to when we covered it. The proportion problems, I think the key, it's just like I wrote, in the email. Proportion problems, I think one of the key things is that you got to think about, um, you know, whatever, just got to think about what's the proportion population, what's the sample population, what am I dealing with? If it's given to me in a percent, I need to turn it into a decimal. So if a 65% of women like cars that are blue, okay, the P pop is 0.65. You've asked me a couple times, how do I get X to determine P? Well, I can get it a couple ways, but I guess the first question is, do I need it? So, for example, if I tell you, Lexi, 65% of all women, according to whatever global survey, like blue cars, and we want to find out how female students at YCP feel. And I tell you that we did a sample of 200, and 29% of that sample like blue cars. Well, first of all, P is 0.29. Um, we used even numbers there, but let's say that we didn't have even numbers. Let's say I said, Lexi, we sampled 168 people and 34% liked blue cars. Well, you could take 0.34 times 168 if you want to get X, but you might not need it because you already have P. You see what I mean? You just got to turn that 34% or whatever I just said into 0.34 and make sure that you've
I think
got,
that's where I was overthinking, is that I didn't always need X, but I was thinking that I needed to find it.
yeah, yeah. And, and then I think once you get past that, um, I think you'll be good. A lot of people get hung up on proportion problems. Um, I don't know. I just probably need to go over 'em more, I guess. But once you kind of get some things identified and get a rhythm to it, I think in a way they're actually easier than some of the others. So,
Once I did the problem I sent, the next one after is similar, just different numbers, and that one I did with no problem.
okay, good. That's good to hear.
So it makes a lot more sense.
Okay. All right. What else? Any other questions? Thomas, what's on your mind? Anything?
I thought I'd just kind of sit in because I normally struggle with the homework as well, but I usually use paper, so I think I'm going to try to switch, kind of watch what you did and switch to try to do Excel, just in case if I do get something wrong, I don't have to do everything over again. It's just for
Yeah.
me, like doing the homework, if I got something wrong, like it's just like extremely time consuming because I have to do like the whole problem over again and then like watch kind of how I input things into my calculator. So it just like eats a lot of time. But if I can switch kind of everything over to Excel and figure out how to or use that more, I think it'll definitely save me a lot more time down the road.
Yeah. I mean, I would agree. And I do agree. Um, it, one of the benefits is when I do something like this. So let's say I have some givens in this gray box, I have some computations, and then I'm asked a what if kind of question. So if I'm asked, okay, so you got a sample size of 16 with the rest of the stuff, but let's say, what if your sample size changed to 160? Well, all I got to do, assuming that all my computations are set up correctly, is just copy that base model, and then I can go to my new model and change that to 160. And, I get new computations. So I don't have to do all that again because I built my base model. All I have to do is to change that. See what I mean?
Yeah, because for me, what I would do is like if I got stuck, I would use like the feature that says like help me solve this or like whatever it says. But then like once I do that, like I have to do everything over again because it gives you like a new set of numbers. So just
Yeah.
like like I'm on a problem for like hours, like trying to figure out what's going on, just because it's like I'm trying to hand jam everything, and then it's got if I make an error, then that's on me.
Yeah.
So I think it's some because I'm not really too familiar with Excel, so it's something I got to work on, but it's way quicker.
Yeah. Yeah. And I think just from a practical point of view, um, regardless of what you're doing or what, you whether you're, working a strictly D3M problem or, people are going to ask you. So if you do something in a calculator, you're kind of a one trick pony and you go into whoever, the commander or the boss or whoever, and you say, okay, here's my answer. And they say, well, and you say something like, okay, we talked to 10 people and they go, well, Lexi, what if we had talked to 20? And you want to be able to just kind of hang with that. And well, Lexi, what if we had $300? You want to be able to just enter that in there because bosses and executives, they like to ask like a ton of what if questions because they usually have more options than you do. And they often have more information available, or they're just kind of thinking out there. So you want to be able to have a model that you can change the variables involved and have that conversation. You know, what you don't want is they said, okay, Lexi, you did this based on a budget of $5,000, but what if I gave you 50 grand? And you're like, and they're like, well, I got to go to another meeting. So you go back and work that. And like Thomas said, you got to work a whole new problem. But if you have a model built and they go, what if I increase your budget from 5 grand to 50 grand? You just punch that in right there. And you could say, oh, well, the profit would be this. And so you can have a much more robust conversation with people because you have this what if capability kind of thing. So that I think is definitely the practicality of working in Excel and building even these little mini models where you can ask what if questions, that kind of thing. So any other things you guys would like to talk about?
I'm good. I think I got it. No.
Okay.
Yeah, I
Thomas?
think I'll just like watch the video because I know like on the squad drive, the proportions part's kind of the part that I had a tough time with as well. So I think I'll just kind of watch the video and kind of get some like repetitions in to
Mob
kind
up
of like,
those reps.
you know, to kind of like build a structure that kind of works for me.
Yeah, absolutely. Now I posted a squad drive solution video about an hour ago.
Yeah. Okay. Yeah, I saw that too, and I saw that because I usually get the answers and then like I kind of like reverse look it up to see like what I did or like what I didn't do correctly. So that's kind of helps me a lot too of just to figure out like where I went wrong.
Yeah, that's great. That's what it's all about. Okay, super. I will just go ahead and stop this recording now.